Thank you for joining this lesson. We're going to continue with physics paper 1, number 4. The question says, a ball is thrown from the top of a cliff 20 meters high with a horizontal velocity of 10 meters per second. Calculate the distance from the foot of the cliff to where the ball strikes the ground. Remember to subscribe to this channel and to also share the link with friends. All right, what we're going to have, let me sketch what is happening here. We're having a cliff here, which is 20 meters high. That is the height of the cliff. And now we are throwing a ball with a horizontal velocity of 10 meters per second. And we are to calculate the distance from the foot to where the ball strikes the ground. So the distance which has been explained here is the distance at this point. If the ball is flowing until it lands at the ground, it covers a distance which we call the range, and the range, capital R, is usually given by ut. That is the initial horizontal velocity multiplied by the time of flight. Again, practically, it's concluded that from this point, if the ball was released freely to the ground, it will take a time, or it would take time, which is equivalent to the time it takes if it is thrown horizontally until it hits the ground. So the time of flight is equal to the time of free fall. That should be known. Again, the ball would be falling through a height of 20 meters, and the height of 20 meters, height is usually given by half gt squared. That means with the 20 meters height, half, and g, which is acceleration due to gravity, can help us get what we are calling the time. Therefore, this will be 5. Then when we divide through by 5, we get 4 equals to t squared. And the value of t will be exactly 2 seconds. Now that we have the value of time, then we will say the same time, because we are saying the time of flight, that is for the case of the ball being thrown, is equal to the time of free fall, that is the case if the ball had been released to fall free. So it should be underlined that the time for free fall equals to the time of flight. Now we can get the range, distance covered from the foot of the cliff to where the ball is going to land. We have said this is given by ut, which means now we need 2 time multiplied by the horizontal velocity of 20 meters distance. That is where the stone or the ball which has been thrown is going to land. I explain one advantage of mercury over alcohol as a thermometric liquid. Okay, mercury is more opaque compared to alcohol, which is almost transparent. Therefore, mercury, to read temperature change on a mercury thread is easier and more accurate than to use alcohol. It can also be noted that mercury has a wider temperature range than alcohol, among other advantages.